Hello everyone and welcome to my presentation for the Atmospheric Dust Conference. I'm really happy today to present the main results from the Atlas side, but the topic will focus on the background aerosol chemical composition and source influences, especially mineral dust. So during the last few years, the measurement at mountainous site have been of great interest. So the atmospheric monitoring program have been established a substantial number of mountain stations, and this for several reasons. First of all, high altitude sites are really important due to their location far from any anthropogenic emissions. They provide information on the levels, the variability, the trend of trace gases and aerosol in the free troposphere, as well as they allow an assessment of the influence of anthropogenic and natural emission sources. So as a result, high altitude mountains are ideal sites for monitoring the temporal variation of trace gases and aerosols in the troposphere in the background levels. So on this map we see the distribution of the mountain stations over the world according to their altitude. The stations presented in this study are located at high altitude above 1,500 meters above the sea level. So in total, the map contains 31 stations. Most of them are located in Central Europe and Western North America, and only fewer are available in the Southern Hemisphere. So second, if we look really the main findings of high altitude sites include source, possible scenarios, and transport pathways. And this previous observation of the long-term transport of pollutants from anthropogenic and biomass burning sources, desert dust, and volcanic plumes from eruption events, we can clearly say that Mountain Value site can provide an efficient channel favoring the transport of pollutant to the high altitude sites. And if we focus on the African or the Africa area, we find three sites previously identified on the map. A site located in the middle Atlas, the Hoga Desert, and exposed to dust transport in the south part of Algeria. So the main measurement carried out are meteorological parameters and gas measurements. The site located in Kenya, and their objective is to investigate the biomass burning transport in Eastern Africa. So most of the stations actually study mainly temporal variation of trace gases. The only exception is Izana, which is a site located in the Canary Islands. And well, a big question mark remains concerning the aerosol composition in continental Africa. For this reason, the Atlas Mohammed V, it's an atmospheric research station, was created in 2017 with the collaboration of University of Mohammed V, the CNRS of ICARE in Orleans University, and also Tropos Institute in Germany. So the station is located at Mischliefen in the Middle Atlas region with an altitude of 2,000 meters above the sea level in a remote hilly site. The station is surrounded by cedar forests and pasture land that come to life in spring and summer, which is a sharp contrast to the hot, dry climate that surrounds the site, with rich in biodiversity. So the strategic location of the AM5 site, situated at the center of Morocco, not so far from Saharan dust in the south, close to the Atlantic coast, and the left, where the most of the industrial activities happen in the north of Europe coast and the Mediterranean as well. So the goal of the study is first to quantify and characterize the variability of the atmospheric composition in high altitude, especially in the Middle Atlas region, determine the background inorganic and organic composition of the aerosol particles, and second is to investigate the role of day and night variation, especially concerning regional circulation of the aerosol chemical composition evaluate the role and the impact of sarin dust of PM10 mass concentration, and identify potential sources who could contribute to atmospheric particle concentration, and finally provide new information into the changes in atmospheric composition over time that can be useful for assessing regional air quality and relevant mitigation strategies. And now that we presented the site, we need to take a look how did we collect the samples and what are the different laboratory analyses. So we used a digital day and night protocol sampling 12 hours regime on quartz fiber filters that was frozen and transported later on to Germany. 200 samples were collected from August to December 2017, and different laboratory analyses are shown in the schematic were performed, such as organic, elemental, carbon, trace metal, ionic analysis, hydrocarbons for PAHs and alkanes, and different organic compounds. And different conversion factors were estimated or were used to estimate organic matter, sea salt, and non-sea salt sulfate. And the water content of samples was estimated according to the extended aerosol inorganic model. Let's take a look on the results bar right now on the PM10 variation. So we see that PM10 shows PM10 mass shows a strong temporal variation with an average of 29 microgram per cubic meter. Highest concentration was observed during August, while the lowest concentration was recorded in December. So about 145 micrometer as a maximum and 9.6 microgram per cubic meter during winter time. So the monthly variation actually shows really a decreasing trend from August to December, and high concentration were observed during August, which could indicate the presence of dust events during this period. It is important to notice that the typical background PM10 mass concentration in the Middle Atlas region can be defined as a minimum concentration around 10 microgram per cubic meter, which could be stable and representative of periods of little external influence. So the calculation of back trajectories using the high-split model allowed the identification of several removed sources of PM10 at the station. We could find 4 main air masses category, which is identified here in the left in the figure. So the first air mass that spent the last 26 hours over the Atlantic Ocean of high altitude above 1,000 meters above sea level is a representative of typical background air mass conditions, which represent 5.3%. We had also 3 other air masses originating from the Atlantic Ocean crossing the coast of Europe, representing 26%, and air masses coming from the Mediterranean and the coast of Europe were the most dominant, about 37% of all samples. And finally, we had air masses originating from the south and eastern Saharan crossing the desert at different altitudes before arriving at the EM5 station and influencing about 22% of all the samples. So if we look closer to the chemical composition, so first starting by the background composition is dominated by inorganic species such as local or resuspended mineral dust, so about around 61%, and the remaining part is dominated by organic matter, but also main ionic components such as sulfate or nitrate. The sea salt remained low due to the distance separated the station from the coast, and the low concentration of EC indicate that the local anthropogenic influence is minimal. But during dust event, the mineral dust contribution reaches 84%, which is a huge impact on the background chemical composition. It is also important to notice that high sulfate was noticed during this period, and we found that there was a correlation between non-C sulfate and also non-C calcium during dust event, which could actually explain the higher concentration of sulfate. The long-range transport of mineral dust has a significant impact on atmospheric and aerosol chemical composition. So the PM10 concentration increased with an increase of mineral dust content, as we can see in the box plot just in the left. And we also we could use the iron aluminium and iron calcium ratios to make distinctions among dust sources. And we noticed that we had higher ratios of iron aluminium during background conditions and lower during dust events. We also noticed an increase of biogenic organic compounds such as biogenic alkanes, which increases during dust event, especially old alkanes such as nonacozan, hentriacozan, or heptacozan, which could indicate that mineral dust had a common source or was loaded with biogenic material around the site. The chemical composition of the organic fraction indicates that there was no strong influence from any anthropogenic sources, which could explain why we had so often higher biogenics than any anthropogenic tracers. So the dust was not influenced by any anthropogenic sources. So the last point of my presentation is to investigate the day and night variation. And we can clearly see that there was an increase of mineral dust during the day due to traffic, and which could be related to resuspension of road dust. We had also high organic matter during daytime. Often we saw that there was a slight increase of alkanes, shows that the main source of organics was biogenics, stated previously. We had an increase of EC and heavy metals observed during the evening due to the change of the boundary layer thickness, and finally the difference in concentration between day and night could be explained by an upslope flow resulting from the combination of different transport mechanism in the mountain area. With this, I would like to summarize all the important points that I presented in my talk. So first, I showed you the seasonal variation of the PM10 with higher concentration during summer, especially due to the dust event, and significantly decreased until autumn, winter because of the higher precipitation and less influence from Saharan dust. So I showed you the background chemical composition, which is mainly dominated by road dust, and biogenic materials shown by the high contribution of alkanes. I showed you also what are the different sources influencing the chemical composition, and despite the proximity of the site to the Saharan dust in the south and in the east, the influence of dust represent only 22%, while the marine influence is more significant at 64% from the Atlantic and the Mediterranean Sea. And finally, the day and night time variation of the particles is related to resuspension of road dust during the daytime, and we had an increase of anthropogenic traces such as elemental carbon or anthropogenic metals, mainly due to the boundary layer variation, especially during the nighttime. With this, I want to thank you all for your attention, and I will be glad to answer and to get a feedback from you and to answer any question you have about my results. Thank you all.